Thank you, first of all, for the invitation, ASHRAE and the Hellenic chapter, and thank you basically all of you that stayed that late. I have two good news for you before I start. The first one is that I'm the last speaker, so we're going to be soon over, so thank you for your patience. And the second good news is that I'm an architect. I'm not a mechanical engineer, so I'm going to show you just pictures and videos, and we'll be very fast. So, I'm Panos Parthenios. I'm an associate professor of the Technical University of Crete. I'm also an architect. I'm running Parthenios Architects in Greece, in Athens. And I'm also the director of the Digital Media Lab in Crete. So I'm going to show you some research we do in the postgraduate program, along with my PhD students, on the umbrella of the smart buildings, smart tools, and smart users. This is under the bigger umbrella of the smart ecosystems, and I'm very happy to see that the previous presenter touched on so many of the things that I wanted to show you. So it's a very good, I think, mergence towards what we prescribe as smart ecosystems. First of all, we start from the bigger scale, which is the smart grid. So it's the whole package of power, the network of power, how we produce power, and how everything is linked together. Then we go to the smaller scale of the smart city, which is such a hot topic, and everybody keeps talking about it. And by smart city, we mean lots of things. We mean smart government, smart manufacturing, transportation, digital citizens, and stuff like that. And then we go down to what I think is most interesting, which is the smart people. Users, humans, because what are you going to do with a smart city if you have dumb people? But what is a smart city, really? Let's see if this is going to play. It's not going to play the whole thing, but we'll try. I don't want you to hear this. Okay, there's no sound. Can you do something with the sound? Anybody? I need some sound, please. Thank you. Nothing. I asked for the sound and the internet yesterday. Sorry for that. Very loud, I think. Careful, it's going to be very loud.
Our team, called the Smart City team, that was in charge for
It's okay, we're not going to see the whole video in any case.
coordinate and centralize all the projects that we're running here in Barcelona.
But what was important was, and I'm going to skip this video because it's okay, don't worry about it. What's important is that we're talking about smart cities as if something that we know. And we talk about smart cities without asking the people who live in the smart cities how they want a smart city. And it's exactly what it was described at the first minute of the video, that smart city is like a teenage sex. People talk about it, but nobody knows what it is. So, let's go down to smart buildings. We are architects, first of all. So buildings for us are manuscripts of human evolution. They encapsulate history, they represent civilizations, and they embody the spirit of the age. So buildings are not just structures. Don't forget that we live almost 90% of our time indoors. If you see the graph there. And when it comes to us architects, and showing that slide before about how important the concept is at the design stage in defining how a building could perform, we begin to talk about the hybrid space, which is emergence between the physical space and the digital space. Data and data and data keeps coming in. So what we're interested in is how these things, physical space and digital space, come together to form the hybrid space. What are the components of a smart building? First of all is what we'll know as sensors, which measure all kinds of things inside a building, temperature and humidity and electricity and comfort levels and stuff like that. Second is the whole idea of Internet of Things and connectivity. Today we have thousands of appliances that interact with each other. That was not a given a couple of years ago. Its box was closed, it was a black box and nothing could communicate with each other. So today we have so many devices that speak to each other besides a BMS that it's a black box. And what we think is more important is we have users. And users are not just people. Like usually engineers think that users are only people. For us users are people plus processes. Because we are interested in what people are doing, how people are behaving. So how can we actually evaluate what we call user experience? How we can engage and educate people? Let's see if this video is going to play with sound. Hopefully.
This is Noah, and this is Sonia. Both buildings are similar, but one has an advantage that is helping businesses around the world save time, money, and the environment. What's the difference? Sonia is a smart building. What makes Sonia a smart building? It's a system that collects and makes sense of thousands of sensors, generating data all over the building. These sensors collect all kinds of information, things like energy usage, space utilization, and occupant productivity, providing better insight and control over a broad range of systems that span the entire building. But it's not the sensors that make a building smart. It's the ability to process and learn from all the data those sensors provide. Take a typical day in Sonia's world. Sonia monitors the entire building, everything from elevators to heating and cooling, room usage, and of course, the coffee machines. Sonia can see what areas are drawing the most energy throughout the day and suggest ways to remedy inefficiencies, reducing utility costs. Sonia also knows which areas of the building are more frequently used. They can plan and optimize space utilization and maintenance based on work schedules. Which is great, considering 39% of workers prefer a flexible workspace and don't necessarily need a desk every day. Sonia also works with the building's occupants, providing personalized comfort regardless of location, custom workspace and collaboration environments, and guidance to your next meeting. And all of this works together because of an integrated data system that orchestrates not just the individual systems, but the building as a whole, improving performance and comfort across the board, which is good for you, but it's also really good for the planet. Many buildings, like Norm, aren't connected yet and don't have these features, but smart building technology can be implemented in existing structures.
So basically, you get the idea. Is this short video shows lots of the things that we already talked about and the importance and the focus on users. So the technology we use is, first of all, in smart buildings, it's what we know, all of us, the facility management. So for example, the same way that a plane has a black box, the same way a building has what it used to have, a BMS, so it's like a building's black box, but we need more of that. We need to tackle inside the data that can be stored inside the building's black box. And we need to integrate the infrastructure into the design process. And this comes to what we heard before about bringing us architects early in the process and collaborate with us so we can take this data from previous examples like cooling, heating, ventilation, density, occupancy, natural lighting, take all this data and how people have been performing on a building and incorporate it on the very early stage of design so that we can design better as architects. And the design process can be improved a lot. Also, when you have a smart building, it can be automatically, let's say, benchmarked without having to have measures afterwards in order to measure it. The building itself can talk and give data outside, so it can be automatically benchmarked. And also, of course, we can have energy reports, and we can reuse the building. We can do all this notion of adaptive reviews when we know how the building has been performed in the past, when we know the building's history. All these have been said before today. But think for a moment that the Internet of Things is going very, very big. By 2030, there's going to be 25 billion interconnected things. Think about this number. 25 billion things are going to be talking to each other and transferring data about everything. And utility companies will collectively save up to $157 billion by 2035 only by the use of IoT. Think of the opportunity there. But the value of information, we believe, lies in the human being's ability to interpret it. This is what I said before. What are we going to do with smart buildings if we don't have smart users? So what's next? We as architects, and the research we do at the Digital Media Lab and the university, and the Technical University of Crete, we analyze user needs to understand user behavior patterns. So with these patterns, we can design better in the next buildings. And a very interesting idea is this idea von Hippel that users can act as innovators. So the single user can be an innovator, a disruptor, as it was said before, because the user itself can ask for a change. Learning by doing, customizing the process, and giving incentives to users. It's the same way that software architecture evolves. Think about from one version of a software to the next. Usually, it's because user asks for something, or users find bugs that don't work, so the next version is better. Think about the users of a building asking this kind of improvement for the building itself. Not only to the next building, but to the building as an ecosystem that evolves all the time and can be changing all the time. And of course, this notion of a knowledge database and all the notion of the building information modeling that many of you, I'm sure you know, is something that has been said and was around many decades ago. Nicolas de Greponder, a couple of decades ago, imagined a model not just as a three-dimensional picture of a geometry, but a rich representation of the building that contains all kinds of interesting and useful data. And BIM today, BIM software, even though companies are claiming that it's there, it's not there yet. There's a long way to go to get all this data inside. So we're talking about a building that evolves according to the user's demands, and think about it the same way as we have Dropbox as a platform as a service, Google Apps, software as a service. Why not have building as a service? Think about the building as a service and not as a structure, not as a solid structure. So how are we going to use this information? This is an example of a project we're doing in a big office building in Bucharest. We have designed a platform for each user so that the user can get information such as weather information, travel time and distance calculators, building and tenants info so everybody knows where everybody is, like a tenant directory. Energy consumption, but per tenant, per floor, per group, per tenant, down to each user. Building a real-time info about energy consumption as a building, and some funny things such as indoor fitness calculator. So, for example, you get motivation as a user. If you don't use the escalator or the elevator, you can save that amount of energy, and you get these many points that you can buy coffee with these points and stuff like that. At the same time, you're saving in your fitness calculator. And of course, there's another notion that I'm not going to talk about it too much today, about the AR module, the augmented reality. I'm just going to show you a few videos at the end, how augmented reality can interact with the building and the users. Access control, occupancy, evacuation, all these kinds of things. I'm not going to go into detail, but the idea is each user now is able to talk with the building, and it's able to talk with the rest of the users inside the building. And yes, we're able to track its individual user with a very big accuracy. There's a new software out there on how to do that without beacons, without sensors, without Bluetooth, just with your cell phone. So, is there a critical view on all this? Let's hear a few things.
I turned my one-bedroom apartment in San Francisco into a smart home. Basically, the goal of the experiment was to find out how much it would be monitoring my family and myself. I already had an Amazon Echo, the smart speaker, we had a Vizio smart TV, but I bought a bunch of other devices. Internet-connected toothbrush, internet-connected coffee maker, a mattress tracker that went over our bed and tracked our sleep, smart lights, also a internet-connected baby monitor. My colleague built a router that I connected all the devices to, and that router kept track of all the data they were sending. Alexa, play music.
Here's a playlist you might like.
Ask Roomba to start cleaning. Turn on the living room. One thing we discovered is that the devices, almost all the devices, talk to the companies that made them every single day. So, for example, we bought smart light bulbs from Philips and also a smart toothbrush from Philips. And so Philips knows about our light use and our toothbrush use. It was kind of just disconcerting to have third parties know every time I use a device in my home. It's not necessarily sensitive information for, iRobot to know that I vacuumed my home, but it's just kind of strange to be tracked at that level in this.
So you get the idea of, we're having all these devices around us that are watching what we do. And okay, it's not sensitive information, but we don't necessarily want to be tracked on every single thing that we do inside our private space. Just to have this as a back of your head. So here are some examples of this application, the Eco-Motivate application, that we actually get the users motivated in order to save energy themselves. And we have started a research collaboration with some hotels like Greg Hotel and Ambassador's Residence in Crete in order to test these applications in their hotels and see if each user at the end of the day will save some energy, would get motivated to save energy if he has a motivation system of, if he saves that many points of energy because he turns off the air conditioning or the water or stuff like that, if he gets a motivation of getting a free dinner or something like that, let's see if that would make him save energy, and at the same time, the hotel also gets big savings on energy and promotes itself as a green hotel. It's not about being green, but it's more about taking the users to make a building green. It's a different approach, if you wish. And also the idea of using augmented reality, as I said before. So, for example, you can, with your cell phone, you can point on different things inside your room, and you can see on your cell phone how these items perform in terms of energy and if they're green or not, in a simple output. And I'm going to end my presentation with a few slides about the technology we have today that is able to get all this data. We do a lot of 3D scanning in tons of things. Today it's very easy and very cheap to get 3D models of everything. You get tons of data about buildings just with your cell phone and just cameras without any expensive laser scanner or stuff like that. And if you think about it, the tools that we have today as architects and as engineers are so powerful. This is not going to play. That was a video, which is, okay, is playing, from a small monument in Crete that we scanned using only our cell phones. And this is an online platform that is for free, so anybody can go there. So you can scan your building and you can actually go and play with it, and you can send it to your client, walk around, have it in real scale, get drawings out of it and stuff like that. So think about the possibilities that come in front of you for free, completely free, with the ability so easily to scan the environment around you and have this information available on the internet to anybody. Very light models and accurate on scale. This is a video from the platform that somebody can play inside it on the internet. So if you have all these devices and you have all these Googles today, that are getting very, very cheap, you can actually begin to navigate inside your environment, right? There are devices that track your position and your perspective. So you're actually, this is a scan model of a cave, and you see on the left the person that is actually moving around, and the feeling you get in the scale is really amazing. So think about this tool if you put inside this model also information about your building, about energy, about consumption, about leaks, about other things. This is what we call augmented reality. So if you bring different nodes of reality inside the virtual world. And of course, as architects, we have other beautiful tools where we can actually walk around and design in real time, in real scale. Look at the rendering ability of these machines. This is a virtual environment where we as designers can walk around and literally at the same time change materials and colors and stuff like that. And we are happy to get all this power. Where from? From a big industry, which is the game industry. The game industry, which is a multi-billion-dollar industry, has created these game engines, Unreal and Unity, that you probably know. So we as designers can use these tools in order to, in real time, navigate along with our client and change the properties of the object. Now, it's not only about the materials and the light. Think about energy here, okay? Think about data, and think about user involvement inside this environment. So the possibilities we have are today huge, and I'm going to close with this slide, which is one of my favorite because we're talking about an emotionally smart ecosystem. We're not talking only about structure and bricks. And the building today knows. The building can act, can react. The building can feel and react to what people need or talk. So in one way, it could sound scary if I can react and the building can react towards me, but on the other hand, it's a big, big opportunity for us designers to design it properly so that the users can be the real winners. So thank you very much.